Welcome to Podcasts by TechNation. This is a series of podcasts focused specifically on the biomedical and HTM industry. New episodes are added monthly. Listening to each episode is eligible for 1 CE credit from the ACI. At the conclusion of this episode, you'll be able to access a link that will take you to a quick survey. You'll be able to download your certificate once you submit your survey. Before we begin today's podcast, I'd like to invite you to save the dates for our upcoming HTM mixers. We'll be in Milwaukee on July 14th and 15th and in Kansas City on September 9th and 10th. Please visit htmmixer.com for details, registration, and our steps to a safe and clean meeting environment. Podcast on TechNation would like to thank our sponsor, Medigate. Medigate's comprehensive and accurate device discovery capabilities combined with clinical contextual anomaly detection, enables automated, rule-based, clinically driven security policies that keep clinical networks and patients safe. For more information, please visit medigate.io. In this episode, we are joined by Jonathan Langer, CEO and co-founder of Medigate. Jonathan, you may begin whenever you are ready.
Thank you very much, and thank you for everyone that has joined the podcast. The topic that I will be covering today is the evolution of IoMT risk assessment. Now, the thing that I'd say the overarching principle that I'll be touching on today is basically how do we use contextual risk assessment for HDOs in a way that is actionable in reducing risk. We're going to talk about several topics that relate to that. So in terms of agenda, we'll talk about how technology can drive risk management. I'll use that as an introduction to the topic in general. But then we're going to dive into the risk management framework that we've built at Medigate, and hopefully that'll be empower people to use that in their own HDOs in a customized way. We're going to talk about HDO risk overview from an enterprise perspective and how to get a high-level holistic view of risk in an aggregated fashion. And then we're also going to introduce the concept of identity-based risk management. That's basically discerning between IoMT devices, IoT devices, and IT assets within the healthcare enterprise. So that's what we have in agenda today. And I'm going to jump right into it with the following. So first, let's talk a little bit about how technology can drive risk management. If you are going to use a technology for device discovery, regardless of the vendor of your choice, that could certainly be helpful in order to get a foundational understanding of your device inventory and comprehensive network visibility in an HDO. It is possible to obtain an inventory manually, and a lot of HDOs are still working that way. But if you want to introduce some automation, technology can definitely drive that. Now, the tricky part is, and this is where I want to spend most of our time today, is I want to explain how you actually operationalize this ocean of information that can be obtained through the visibility in order to actually achieve a risk management program that drives decision making and ultimately increased patient safety and privacy. The thing is, and I'll keep mentioning this throughout the podcast today, is making that data actionable, operationalizing that data so that we have a clear outcome in a fairly easy process in order to build that risk management framework. I will say that since we're talking about risk management today, it's also important to note the stakeholders. So when we talk about risk management within the context of a healthcare delivery organization and the various assets that you're going to find in such an environment, certainly InfoSec is going to be a partner here, a stakeholder, and naturally clinical engineering as it relates to the BioMed devices. IT, and we'll talk about IT more later, is also going to be a stakeholder, especially as it relates to risk mitigation of some of the devices. So I would definitely include them as a stakeholder as well. One side benefit of this discussion, by the way, that I do want to call out is that when we use technology in order to drive risk management, the side benefit as we identify the stakeholders is also bringing them closer together and finding a streamlined process that actually fosters collaboration between the various stakeholders. We'll talk about that more later in this discussion, but I think it is important and quite a significant byproduct of this entire discussion. Let's dive into the risk assessment process. So the risk assessment process, in real high level, I would basically divide it into 4 parts. It's about discovering the inventory, correlating vulnerabilities against the technical attributes of what you have in your inventory, making a risk assessment of the specific device, and then elevating the discussion to understand what the enterprise level risk looks like. So I want to say a couple words or to provide a little bit more detail about each one of the stages. Let's start with inventory. So when we talk about inventory, basically what I mean by that is that we need to discover and identify all the connected devices. And by the way, the devices that are not connected as well, especially as we're talking about IoMT devices, with the most granular detail possible. And the reason why the detail is possible, the granular detail is highly important, is it because it relates to the correlation of vulnerabilities, which I'll speak about next. Inventory, as I said previously, that can be achieved manually, that can be achieved with automation. As organizations scale, and we're seeing more and more devices connected in the environment, it's probably going to be easier to do this in an automated fashion. Next stage of the risk assessment process is correlation of vulnerabilities. What does that mean? Every vulnerability that comes out there can exploit potentially some software or operating system that is installed on the device. So going back to the importance of granular detail with regard to the devices that are part of your inventory, this is where it comes in real handy. And I'll give a couple of examples later on. So when we identify the technical attributes of the device itself, we can then correlate the relevant vulnerabilities that pertain to these specific technical attributes. That's the correlation stage. I'll go to the third stage, the assessment stage. What we're going to do here is on an individual level, on the device level, we're going to assess the risk of a specific device based on the correlation of vulnerabilities, but then also on the network posture, what the network looks like, what kind of compensating controls we have there. And that's going to factor in very nicely into the risk assessment. And of course, I'll provide more detail later. One last thing within the assessment stage that I want to call out, and this is highly important for HDOs, as far as I'm concerned, is also to understand the clinical severity or the severity of harm of the clinical assets at hand. So what that means is that we have to understand the context of the device itself as it relates to patient safety and patient privacy. Every device is different in that regard, and I can't stress enough the importance of that context for basically making decisions that relate to these devices. Lastly, the last stage of the risk assessment process is what I call enterprise level evaluation. This is where we take a step back or zoom out basically and say, we're not going to look at a single medical device or single device on the network, but we're going to look at a site. Maybe that can be a clinic, a hospital, or maybe we can even zoom out further and look at a healthcare system in general. Now, once we're able to identify varying levels of risk throughout the entire enterprise, that is the way that we're basically going to come back and say, now we can make recommendations as to what type of action we need to take that will be most efficient and most effective. When we do that on an enterprise level, the advantage of that is that we're seeing the entire picture. We're not just looking at a single device kind of randomly. We have a holistic, broad picture, and that just gives us better decision-making capacity, which is why this is so important. So just to replay that for everyone, 4 stages of the risk assessment process, and then I'll go to examples. We got our inventory stage, we got our correlation stage, we then have an assessment stage, which is done on a single device level, and then we'll do an enterprise level evaluation for the entire inventory. Now let's give an example. Let's say we have an infusion pump that's connected. So we're gonna see that on the inventory. Then based on the, let's say the operating system, let's say it's a Linux operating system, version this and that, we are going to correlate all the relevant vulnerabilities to that operating system or to other software that's installed on this infusion pump. Then we're gonna do the assessment of the single device that is on the network. Now, rinse and repeat, we're gonna do that for every device that we have on the network, BioMed devices and non-BioMed devices. And once we finish that process, we'll funnel up all the information, all the single device risk assessment that we did in order to get that enterprise level evaluation. And that's where we'll be taking action when we have that entire picture. Now, I'm sure that many of you are listening to me and saying, okay, well, it's one thing to do this on a single device for one device or for one fleet of devices. How do we do this for everything on an ongoing basis? This is really where automation comes in handy. But I don't want to spend a lot of time on tech today. I want to talk about process, and this is basically the foundation of the process. So that's risk assessment in general, the framework. Now, what I want to do here is I want to hone in on how we actually determine the risk of a single device, what we look at, what kind of considerations we have that will enable you to say, hey, this infusion pump is a high risk and this other infusion pump is medium risk and this MRI is low and you're good to go and there's no problem at all. So what we did at Medigate is the following. We looked at all the guidance that is out there, the industry specific and the non-industry specific guidance that's out there. So to name a few, AMI, NIST, we looked at Joint Commission publications, ECRI, FDA. We had a pretty wide look. And what we came back with is a pretty simple yet important concept that is really the foundation of the risk assessment framework in general. And that is the notion of probability times severity. That's the basic equation that we have here. The tricky part is how do we determine the probability of an incident and how do we determine the severity of a single device, the severity of harm if a device is impacted, but how do we do so within the context of an HDO, where the clinical attributes play a big part? Again, we're trying to reduce patient safety and patient privacy concerns. So that's one aspect of this. And the other aspect is how do compensating controls come in as a means to decrease inherent device risk? Those were 2 key takeaways that we came back with. The other piece, and I want to double click on the severity for a second, is that there are definitely guidelines, especially as they pertain to FDA, ECRI, and the Joint Commission, that basically are able to analyze the clinical functionality and account for that to produce a context-aware impact of harm score. That is incredibly important. Probability, it's not, there are other parameters that we look at. I'll go into that for a second, in just a second here, about the network itself, the compensating controls, but the severity of harm, in many ways, this relates directly to the clinical functionality of the device at hand, and it is key to have a very good understanding of what that device does. One more thing that I want to say about the concept of the risk assessment in general is that what I've seen based on my experience talking to many healthcare delivery organizations, providers out there, is that everyone does things a little bit differently. everyone perceives risk and the various risk parameters, the weightings, a little bit different as well. And that's okay. That's understandable. That makes a ton of sense because everyone accepts risks differently. So one key thing to remember as we address risk assessment frameworks is that they have to be customizable. I can't stress that enough. There is no one size fits all. That's a strong conclusion that I've reached throughout the last couple of years. So I want to dive in deeper. I want to double click on that. So how do we determine probability of an incident? The way that I look at probability of an incident, I want to look at two key parameters. I want to look at the inherent device vulnerability, and then I want to look at the network. So when I talk about device vulnerability, what do I mean by that? First and foremost, we need to identify the operating system and the software that is installed on the device. It could be as it relates to the operating system, it could be Windows, it could be Linux, it could be something else. And we have to understand the exact version. Again, that's how we map vulnerabilities to this. Same thing with all the other software that may be installed on a device. It could be commercial off-the-shelf software, it could be other software. Once we have that, it's not easy to get all that, and I don't want to spend a ton of time talking about a SBOM or software bill of materials. I'm sure some of you have heard of that, maybe a topic for a different podcast, but certainly that can be very helpful as we think about the future and how to obtain this data from the various devices that are installed on our networks. But once we have that, we want to map out vulnerabilities to the software and the operating system that we have at hand. Those vulnerabilities, they're going to come in with an attached score, their CVSS score, or other metrics that allow to understand the severity of these vulnerabilities. And that's a big key thing, a key parameter that we need to look at. One other thing that we need to look at is whether the firmware that we have on the device is outdated or not. We can know that based on what the manufacturer has put out there in terms of versioning. More often than not, this is information that not easy to get your hands on, but it is available. And also, I want to look at whether the manufacturer installed some sort of antivirus or not on the device. That's definitely something that I want to understand. So all of these parameters or subparameters constitute the device vulnerability. And that should be weighted. That's one aspect as it relates again to probability. The next thing that I want to look at is the network. We're talking about connected devices in an HDO. So what do I want to learn about the network? I want to learn about the connection type. It's easier to take advantage from an attacker's perspective of some connection types over others. So if I have a device that is serially connected to the network, and we still have some of those legacy devices out there, or actually have a lot of them still, that's going to be harder to exploit, harder to attack than something that's on Wi-Fi or Ethernet. Other thing that we want to take into consideration is the VLAN topology. So obviously, we're going to want unified VLANs, meaning medical devices, specific as you can be on specific VLANs, and not mixing them around with other devices. That would be, of course, a best practice, but it's not reality for many healthcare delivery organizations just because of the scale and the level of connectivity. But that is something that I want to look at. Obviously, the network is easier to exploit if we have a mixed medical and non-medical VLAN versus something that is unified. We want to see if there's internet communication that is enabled through the network, and we also want to see if there are any compensating controls on the network level itself. I don't want to get too deep here, but of course, if we have some form of network segmentation, whether it's SGTs or DACLs or firewall rules that are segmenting the network in some ways, this is where the discussion with the IT folks or the IT security folks can come in handy. That's definitely something that we want to take into account. All of these things, they roll up to or constitute the network parameter. Network and device vulnerability parameters, that's how we determine probability. That's the way that we've done this at Medigate. Now we want to understand the severity of harm. So severity of harm, as I was underscoring previously, the main thing here that we want to do is we want to be able to take into account the clinical functionality of the device. This is key, again, to patient safety and patient privacy. So we want to look at several parameters here. We want to understand the FDA class type, 1, 2, or 3. That's going to give us I'd say, some sort of understanding as to how invasive the device could be from a patient safety perspective. It's going to be a rule of thumb that we can use. We need to understand whether the device houses PHI or transmits PHI, yes or no. By the way, MDS2 forms can certainly be helpful here as it relates to these things. These are questions that exist on the MDS2 forms. So definitely you can look at that and that can help inform these parameters. And then you also want to look at the equipment class and the consequence of failure. These are the Joint Commission parameters. Some of you may know this from the TJC literature. I would definitely look at that. That can inform the severity of harm as well, and the financial cost of the device. If you can get your hands on that data, that would be great. So when we look at all of these parameters, again, the FDA class type, PHI, yes or no, equipment class, consequence of failure, financial cost, we bundle all of that into the parameter of severity. Now, severity and the probability together, that's what's going to determine your risk. So I know that's a lot. That's a lot to take into account, but I think it's going to give you the best contextual understanding of a single device risk score that you can come up with. As far as I'm concerned, that's going to be helpful, but what's going to be even more helpful is to get recommendations or to come back to the organization with recommendations as to how you can lower the risk score. And I think this opens up a really important conversation. As I was saying earlier, there are a couple stakeholders that may be relevant here. And I think this does open up kind of a joint conversation that I would recommend. So what could recommendations actually be? One recommendation can be basically a remediation or some sort of patching that we might be able to do here. And when it comes to the BioMed devices, I'm sure everyone on the podcast is aware that this requires the consent and the approval of the manufacturer. There has to be a certified patch out there or some approval to update the operating system from the medical device manufacturer. So we can certainly automate that, or at least show what kind of options are available out there. And what that will do is that once you're able to install that software version, that new patch, basically some vulnerabilities that pertain to that patch will be remediated at that stage, and the risk will be lowered, of course, because now we've lowered the inherent risk of the device. Remember, we talked about probability before, and this is going to lower the probability. One other thing to look at, and it's not the topic of this presentation, so I'm not going to go too deep into this, is various forms of segmentation. So there are a couple of options here that you might want to consider, whether it's blocking some of the unnecessary internet access, maybe changing the VLAN topology, moving a device from one VLAN to another. A good example, you certainly don't want a medical device on the guest network. That's obviously something that we would want to refrain from. And deeper forms of enforcement using DACLs, SGTs. We won't talk about that today, maybe a conversation for the future. Again, I do want to underscore this because I think it's highly important. This really goes to governance. So in this stage of the conversation, we're going to need clinical engineering, we're going to need information security, we're going to need IT in order to come back with joint risk reduction activities that are going to lower that risk score that we had talked about previously. So that's, again, just underscoring the importance of recommendations. I would definitely encourage that. I want to come back to what we talked about previously in terms of enterprise level evaluation, and I want to explain what that means. Up until now, or in the last couple of minutes of me speaking, we've really been talking about that foundational risk assessment on a single device that is connected to the network. But as I said previously, as part of the framework, we want all of that to funnel up into an enterprise-wide view. If we're able to do that with automation or without automation, doesn't matter for the purpose of this discussion, we're going to understand what the various risk contributors are, the various what actually poses risk to my network. And it could be a bunch of devices that have outdated firmware. It could be specific vulnerabilities that have an adverse impact on the risk score. It could be outdated operating systems. It could be too much internet communication. It could be network topology that is causing the VLANs to be mixed up. It could be a multitude of different things. But when we look at this from an enterprise-wide perspective, that's where we're gonna that's where we're gonna be able to make better decisions based on the data that we're seeing. So again, the importance here, I do want to repeat this because it's important, is that sometimes we get pressure from leadership or from various people in the organization that would come back and say, hey, I saw this vulnerability in the newspaper. What are we doing about it? It's a totally valid question, totally legitimate question, but in order to be sure that we're not chasing our tails and going after the vulnerabilities that are not as important as others, if we look at this from an enterprise view, we're probably going to make the right decisions rather than doing this kind of randomly based on the latest thing that hit the news. And unfortunately, there's a lot on the news these days. So that's the importance here. Now, when we consider the activities, the risk reduction activities that we can do, and again, it could be activities that are done by IT, it could be things that are done by information security, it could be things that are done by clinical engineering. Usually, it's the three. When we do this again at the enterprise layer, we have to take into account what's going to get us the biggest impact, the biggest bang for our buck, so to speak, because this does cost money. Patching costs money. Network segmentation costs money, time, resources. These are all big efforts. So when we do the analysis of the various risk reduction options that we have, you need to try to measure what risk reduction is going to look like per activity. Once we have that, we can determine clear priorities and an action plan that will reduce risk. And as far as I'm concerned, that's the biggest takeaway from the podcast today. If we're able to finish this enterprise level risk evaluation with a clear action plan that is quantified based on impact and cost, we're in great shape. At that point, the risk management program has succeeded in doing its role. Not only has it informed leadership of the level of risk that we have in various places of the enterprise, but we also have a clear plan moving forward. And I think that's just terrific. So that would be an awesome outcome. So that's what I wanted to emphasize today about that. Next, I want to double click on a little bit of a different concept, but it relates to this overall risk management framework, is when I look at an HDO, and we mentioned this before, we're going to have multi-stakeholders in the organization because there are so many varying assets. We're going to have IT assets, we're going to have IoT assets, and we're going to have BioMed assets. And they all have different owners and different levels of risk and so on. How do we create a plan that allows us to assess the risk and handle these devices that are all housed in the same network. So I want to take you a little bit deeper here into a concept that, that I'm trying to advocate for, because I think it makes a lot of sense in this mixed environment, that I call identity-based risk management. And there's several steps that I want to walk you through. So the first step is identity-based asset management and tracking. So this maps to the inventory stage that we talked about previously, but with a little bit of a twist here, because now we're talking multi-stakeholder. We're talking about all the assets in the enterprise. So once you're able to really understand the identity of the device, you can also identify the device's security owner. That's stored in various types of inventories, not just the BioMed inventory, but if we're looking at an enterprise inventory, again, now we're taking a step up and looking at multi-stakeholders within the enterprise and not just BioMed. And we're also going to be able to understand the business context and the criticality of the device. Now what we can do is we can do tailored scanning and correlation. I think this is really important. A key discussion that I'm hearing in many HDOs is, what can I scan using a vulnerability scanner and what can't I scan? So in many cases, and this is where the identity comes into play, you're going to be able to scan some devices, let's say a security camera, IoT device, a computer, a mobile phone, so on, but you're not going to be able to scan a BioMed device because it's not safe. So this way, once we have this concept of identity in play, we can inform our vulnerability scanner or vulnerability management system, preferably using automation, so that we know that we're not making mistakes. And we're basically going to be able to tell it what can you scan and what can't you scan. But this is where we discern between IoMT, IoT, and IT. Different levels of risk, different business owners, different criticality, and different levels of sensitivity of the device itself. So that's a big, I think, shift in the way that things are done today. Once we've done the scanning and of course the vulnerability correlation, we determine risk, just like we talked before in detail. We're able to give you a clear enterprise contextual risk and exposure prioritization. But now we're talking not just BioMed, we're talking about everything. We're talking about IT, IoT, the basically everything that is connected to the HDO network. So this really gives you a broad approach. And now, just like we talked about earlier, we can assign for each type of device, how do we lower the risk, whether it's remediation, whether it's risk mitigation, forms of segmentation, how do we do all that? And we're going to try to do that in an automated or streamlined fashion as much as we can, especially as it relates to segmentation, which of course is hard to do manually at scale. So just touching upon that, I really want to underscore that this concept that we call identity-based risk management, it's highly important because I believe that when we look at the various devices, various types of devices and the diversity of the devices within an HDO, and we're assigning multi-stakeholders to look at the overall risk management program, this framework allows us to include every type of device, every type of asset in the framework, but at the same time, treat different devices differently based on their risk, based on their criticality, based on their business owner, and based on their sensitivity and whether they can be scanned or not. And I think that's important to note, again, because of this diversity. One last thing that I wanna call out, because I think it is important, for those of you that are doing scanning or want to check vulnerabilities for medical devices throughout PM, I think one other notable, or preventive maintenance, of course, one thing that I would call out is if you're looking at utilization data, if you can get a hold of utilization data, in order to give you a better understanding of where you should expect the device to actually be not used, low utilization. Maybe it's in the afternoon, maybe it's in the early morning. That would probably be better. This is where you know where you can do preventive maintenance and scanning, security scanning of the device without disrupting the clinical usage of the device itself. So that's definitely something that I kind of more of a in a detailed fashion, but something that I would encourage folks using as we move to these more advanced frameworks out there. So just to maybe quick recap of what we talked about here today. We talked about a tech-driven approach to risk management, basically how to leverage visibility and automated discovery in order to, and operationalizing that data in order to obtain a risk management framework. We talked about the 4 stages of a risk management process being inventory, correlation, assessment, and enterprise level evaluation. We talked about the importance of an holistic HDO risk overview, kind of elevating our view to the enterprise level so that we can understand risk holistically and then prioritize an action plan in order to reduce risk across the enterprise in the way that is most effective and most efficient. And lastly, we talked about the notion of identity-based risk management as we're looking at diverse types of devices, thus allowing us to discern between IoMT, IoT, and IT assets within the HDO. Thank you, everyone that listened to the entire podcast. I hope it was helpful for all those folks that are looking to bolster their risk management frameworks. And of course, happy to help with anything that we can for those of you that need help. Thank you very much and have a good day.